So what if I asked you to multiply, let's say number 1, I had 2x minus 3 times 2x plus 5. All right, I want you to multiply that out. All right, now you have on one of the worksheets today another one of this. You had one like this previously about a couple of weeks ago, and I gave you another one today. You'd FOIL it out. So you'd say 2x times 2x is 4x squared. What's the outer? 10x. What's the inner? Minus 6x. And what's the last? Minus 15. When I combine like terms, what would be your answer? 4x squared plus 4x minus 15, right? Okay. What about if you had this? Something like 3x plus 2y squared. You had that. You had something like that in another worksheet. But if I wanted to multiply this out, what did you write it as to begin with? 2 binomials. Good. So you say 3x plus 2y times 3x plus 2y. That's what you wrote. And then you'd FOIL it out. What's 3x times 3x? 9x squared. What's the outer? 6xy. Now remember, we had the discussion before. Since I'm squaring a binomial, those two binomials are exactly the same, right? So the outer and the inner better be the same. What's the inner? 6xy. So those two are the same. What is the last? 2y times 2y? Combining like terms, what do you get? 9x squared plus 12xy plus 4y squared. Okay, now look at number 3, and that's what we're going to start talking about in a little while. Is something that looks like number 3. What if you had this though? What if I had 2x minus 3? You see how I had 2x minus 3 here? What if I had 2x minus 3 times 2x plus 3? Let's follow that out. What's the first? 4x squared. What's the outer? 6x. What's the inner? Minus 6x. What's the last? Negative 9. Okay, combine like terms, what do you get? Yeah, the out and the inner cancel out, right? That adds up to be 0. So you get 4x squared minus 9. Okay, so let's talk about numbers 1 and 3 then. Notice numbers 1 and 3. In number 1, when I multiplied it out, I ended up with a trinomial. Number 2, I ended up with a trinomial. Number 3, though, I ended up with a binomial. Now, there's a reason you ended up with a binomial in number 3. And that's going to be important with the type of factor we're going to talk about in a little while. If you look at your binomials, all the terms are in the same order. 2x, 3, 2x, 3, right? What's the only difference? The signs. So whenever the first and last terms are identical except for the signs, then you're always, when you FOIL it out, the outer and the inner will always cancel out, and you're left with how many terms? 2. But, you see this right here? This binomial, this polynomial, we're gonna talk about factoring. Remember how we factored the previous ones a while ago? You're gonna factor these. I want you to notice that 4 and 9 are perfect squares. Now, in a previous courses, you talked about perfect squares. Do you remember what perfect squares are? Okay, so let's talk about perfect squares. Perfect squares. So the smallest perfect square is 1. And we'll go ahead and say the next one. The next perfect square is 4. Let's see if any of you remember what the next one is. What do you think the next perfect square is? 9. Very good. What do you think the next perfect square is after that? 16. All right, so, and there are an infinite number of these. So let's talk about what perfect squares are, because that's important with the type of factoring that this involves right here. So your perfect squares, 1, 4, 9, 16, these are perfect squares because if I take the number 1 and I square it, I get what? 1. If I take the number 2 and I square it, I get 4. If I take 3 and I square it, I get 9. Take 4 squared, I get 16. What would the next one?
5,
Which gives me 25, and so on. So those are perfect squares. Okay? Those are your perfect squares. And what will be the next one? 36. Good, because 6 squared is 36. What's the next one? 49, because 7 squared is 49, and so on. There are an infinite number of those. I want you to notice this, though. If I take the square root of these, I get these things back that's inside the parentheses. What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3, and so on. Okay. Now, we're going to talk more about this next class period, but I want you to notice this right here. Y'all see that 4x squared? Do y'all agree? Do y'all agree? I'm going to make it look like this. Do y'all agree I can write 4x squared as something squared? 2x, good. Because, you see, 4 is 2, right? Y'all agree that 2x times 2x is 4x squared? Okay. Minus. Do y'all agree I can write 9 as something squared? Yes. 3 squared. Okay, now this is important because next class period, this right here that you see, that 4x squared minus 9, that's called the difference of two squares. Difference of two squares. So notice this is the difference of two squares because you see difference means subtraction, right? And notice I wrote 4x squared as something raised to what power? Second. And I wrote 9 as something raised to the second. So difference of two squares. You're going to see next class period that once you make it look like this, factoring it is easy. Factoring is easy. So that's where we're headed at. So next class period, we're going to talk about factoring the difference of two squares. And it's going to look just like this. Once you get it to look like this, then you got your answer. You just do one more step and you got your answer. So most students, almost all students, can deal with the difference of factoring the difference of two squares. Factoring a binomial using the difference of two squares. Okay, so that's what we're going to do next class period.